50 million kilometres beyond Mercury, shrouded by an unbroken blanket of cloud, lies a world which, at first sight, has the potential to be far more Earth-like. See that bright point of light out there in the evening sky? That's Venus. It's so bright because it's quite a large planet, about the same size as the Earth. It's not too far away, but in particular because it's shrouded in highly reflective clouds. That's the frustrating but also tantalising thing about Venus. Even through a big telescope, when you look at it, it is featureless. You never see the surface. And that meant that even until the 1950s, astronomers speculated that it might be a living world with jungles and forests and rivers and oceans. So much so, in fact, that when we first sent a spacecraft to land on the surface of Venus, we prepared for a splash landing. Throughout the 1960s and 70s, the Soviet Venera program sent multiple missions to explore Venus. Many failed, but with each attempt, we learned a little more of the extreme conditions on the planet. After 20 years of trying, Venera 13 began its perilous descent. The craft was prepared to withstand pressures that could crush a car in seconds, and temperatures that would melt lead. On 1st of March 1982, the Soviets took the first full-colour picture of the Venusian surface. Even under the most extreme of conditions, the probe sent its precious data home to Earth. Until 127 minutes after touchdown, it finally succumbed. Far from a benign ocean world, Venus is a vision of hell, where no life can survive. So where did it all go wrong for Venus? Well, that is a good question, and it's an important one. It's been said that we won't fully understand the Earth until we understand Venus, and that's because the planets are so similar. Venus is the same size as the Earth. It's the same composition as far as we know. And although it's closer to the Sun, it's not as close as Mercury. So why is it that one world remained heaven whilst the other became hell? Counterintuitively, the surface temperatures today on Venus are hotter than those on Mercury. And the story of Venus's climate is further complicated by the fact that over the lifetime of the planet, the Sun itself has been evolving. As the Sun gets older, the star burns hotter and hotter and hotter. That means that in the past, when the Sun was younger, it must have been cooler. It's called a faint young sun. And that has a big impact on the planets. At the time when life was just about beginning on the Earth, 3.5 to 4 billion years ago, the Sun was fainter. And that means that Venus was cooler. In fact, temperatures on Venus at that time would have been like a pleasant spring day here on Earth. Within a few million years of its formation, the surface of Venus had cooled. The planet now found itself at just the right distance from the faint young Sun for Venus to experience a sight familiar to us here on Earth. The heavens opened. Great torrents flooded the surface. Rivers of water flowed. Venus became an ocean world. The planet's atmosphere allowed it to hold on to the oceans, this temperate, thanks to the greenhouse effect. The greenhouse effect is pretty simple physics. Gases like carbon dioxide, water vapour in a planetary atmosphere are transparent to visible light. That is obvious because there's a source of visible light, the sun, and I can see it. So that radiation falls onto the surface of the planet and it heats it up. The rocks then re-radiate that out into the atmosphere again, but this time not as visible light, but as infrared, which my eyes can't see. Carbon dioxide and water vapour absorb infrared, and so they trap that energy and the planet heats up. Now, that's not necessarily a bad thing. The Earth would be at an average temperature of around minus 18 degrees Celsius without the greenhouse effect. But there is a thin line between heating the planet up and frying it. Gradually, over 2 billion years, the young sun grew brighter. Temperatures began to rise, lifting more and more water vapour into the atmosphere. The greenhouse effect grew more intense. Rain evaporated long before reaching the ground. Venus had reached a tipping point. A runaway greenhouse effect taking hold. Venus's moment in the sun was over. Its cracked surface today is even hotter than Mercury's, making Venus the hottest of all the planets. As the young sun's brightness continued to increase, the effects were felt across all the terrestrial planets. Mars, much further out than Venus, enjoyed its moment in the sun too. With an atmosphere rich in greenhouse gases, rivers flowed across its surface for hundreds of millions of years. But Mars, being smaller than Venus, couldn't hold on to its atmosphere. Much of its water evaporated and escaped into space. Leaving only small traces behind, frozen in patches across the planet, where missions continue to search for the first signs of extraterrestrial life. There's a crater on Mars called the Hellas Basin, which is 1,500 kilometres across and 9 kilometres deep. That means you could put Everest on the floor and the summit would not reach the rim. The air pressure is so high down there that liquid water can exist. So I suppose it's not impossible to imagine microbes coming up from deep below the surface to bask in the midday sun before disappearing back down below again to survive the cold of the Martian night. But If life does exist out there, it will certainly only be simple life. There will be nothing anywhere near as complex as you or me or even this planet. The story of the solar system is, in a sense, a story of instability and constant change, at least for the inner rocky worlds. Mercury has changed its position radically. Its orbit now takes it close to the searing heat of the sun. Venus probably had water on its surface for around 2 billion years before it became hotter than Mercury, and Mars lost its oceans and rivers perhaps 3.5 billion years ago. But unique amongst those worlds is Earth's, because it's remained pretty much like this, liquid water on the surface for 4 billion years, and that has allowed complex carbon chemistry to develop. Today, our planet is dominated by life. It's in every nook and cranny. And look at this place. This is a volcano in the middle of the Atlantic Ocean, and it is literally teeming with life. And think all the chance events that have happened over 4 billion years just to produce the little creatures in this rock build. Life has woven itself into the fabric of the planet. It's an integral part of every continent and every ocean. It plays a crucial role in maintaining the balance of our atmosphere that keeps our planet temperate. Of all the terrestrial planets, Earth has enjoyed the longest moment of them all, but it can't last. Earth will ultimately follow the fate of the other rocky planets, because even though we don't feel it day to day, the sun's aging process is relentless. We can say with confidence what's going to happen to the sun towards the end of its life, partly because we understand physics and the nuclear physics of what happens inside the cores of stars, but also because the life cycle of stars is written across the night sky. Take that bright star there, for example. It's called Arcturus. It's around the mass of the sun, perhaps a little bit heavier, but it's between 6 and 8 billion years old, perhaps 3 billion years older than the sun, and it is now a red giant star. It's exhausted the hydrogen fuel in its core, and it's swollen up and cooled. And that is what we think will happen to the sun in about 5 billion years' time. As the sun exhausts its hydrogen fuel in the core, its outer edge will inflate. It will enter a red giant phase, expanding millions of kilometers out into space. Mercury will be the first to be engulfed. Then, Venus's fate will be sealed. Earth may just escape the fiery fate of its neighbours, hanging on with Mars beyond the edge of the dying star. The era of the 4 terrestrial planets will be over. The lives lived on the surface of one of them, nothing more than a distant memory. But that's not quite the end of the story. Right at the end of the sun's life, something wonderful will happen. A collection of icy worlds that have lain dormant for the entire history of the solar system will awake. These are the worlds that orbit the outer planets, the moons of Jupiter and Saturn. These distant worlds that circle the outer gas giants will begin to warm. like Saturn's moon Enceladus, or Jupiter's moon, Europa. Amongst all these moons, there is one above all others that we think, perhaps, has the best chance of becoming a place that we'd recognise, way out in the cold, distant reaches of the solar system, past Jupiter. Around the icy ringed planet Saturn orbits a gem, Titan. A planet-sized moon, bigger than Mercury. Surrounded by a thick atmosphere of nitrogen and methane, with a surface that has long remained a mystery. The Huygens probe was our first chance to explore beneath the clouds, and its camera sent back these first glimpses of the distant moon. This is a remarkable photograph, and as is always the case in science, the more you know about it, the more wonderful it gets. This is a photograph from the surface of the moon orbiting around a planet over 1 billion kilometres away. So we got a camera down onto the surface of a world in the frozen far reaches of the solar system. What you see here is something that looks like a floodplain or a riverbed, very much like this actually. And we can say that this is a riverbed or a floodplain because these rocks on the surface look like this. They've been smoothed and eroded by flowing liquid. We know these are in fact boulders of frozen water. They're frozen solid because the temperature on the surface of this moon is minus 180 degrees Celsius. And that raises an interesting question. If it's so cold, and what was the flowing liquid? Huygens detected significant amounts of methane, a flammable gas on Earth. But the relatively high atmospheric pressure and cold temperatures at the surface of Titan means that this methane exists as a liquid. The Titan could be wet, not with water, but with liquid methane, driving rock-like chunks of ice down mountain channels and out into open floodplains. Huygens survived for just a few hours, but didn't detect any trace of liquid methane at its landing site. But the probe's mothership, Cassini, remained in orbit around Saturn. A year after Huygens landed, Cassini again flew high above Titan's North Pole and discovered something seen nowhere else in the solar system beyond Earth. Liquid pooling into not just one, but scores of Great Lakes. Cassini discovered lakes of liquid methane. Earth has a strange, cold twin. In some ways, you could just imagine floating in a boat on those lakes and it'll look something like this. Except this would be liquid methane gas. And those mountains there would be mountains of frozen water ice as hard as rock. What's also fascinating and in fact tantalising is that Titan has a complex chemistry, and that chemistry is carbon chemistry, the chemistry of life. So we found molecules like hydrogen cyanide, which are the building blocks of amino acids. We found molecules called vinyl cyanides, which chemists and biologists speculate could form some sort of cell membranes. And so all the ingredients for life are present on Titan. Now, very few scientists think there will be life on Titan today. It is, after all, minus 180 degrees Celsius at the surface. But because of the presence of all those ingredients, it might be a very different story. You warm Titan up. In the light of the old expanding sun, the far reaches of the solar system will receive more solar energy. Titan's atmosphere will begin to warm. Mountains of ice will shrink and melt as temperatures rise. The frozen water they contain replacing the liquid methane. Mountains will become oceans of water. In a strange twist of fate, at the end of the life of the sun, the solar system's last ocean world will wake up to its own biological possibilities. This distant moon will enjoy its brief moment in the sun. It's easy to think of habitability as a permanent feature of worlds, a defining characteristic, if you like. So the Earth is a living planet because it's in the Goldilocks zone around the sun, not too close and not too far away. But things are more complicated than that. Solar systems are dynamic places. Planetary orbits can change and stars can vary in brightness. So planets that were once heaven can become hell. We now understand that the Earth has been a fortunate world, an oasis of calm in an ever-changing solar system that's maintained a stable climate, perhaps against the odds. For the 4 billion years it took complex living things to evolve. We don't know how many planets like Earth there are out there amongst the stars. They're places where the ingredients of solar systems have assembled themselves into structures that can dream of other worlds. But we have to take the possibility very seriously that there might be few, and that would make Earth and us extremely rare and precious.